that stimulates vision or that aids vision. Okay, so here we are talking about electromagnetic spectrum. When we talk about the electromagnetic spectrum, we are referring to classification of waves. So we are classifying waves of similar features. So some waves of similar features. So the groupings of waves with these common features is what we are referring to as the electromagnetic spectrum. And what are these waves? We can talk about gamma ray. The gamma ray, X-ray, ultraviolet, infrared, what we are talking about, visible light, microwaves, radio waves, TV signal. These are the waves under the electromagnetic spectrum. All these waves have something in common. What do they have in common? They all travel at the same speed. So the similarity the waves under the electromagnetic spectrum have is that they travel at a speed of, their speed of propagation. Propagation is 3 times 10 to the power 8 meter per second. So this is one of the features they have in common. 2, the second one is that they can all be propagated without any medium. Okay, so can be propagated or transmitted with or without any medium. So these are the things they have in common. All the waves under the electromagnetic spectrum travel at a speed of 300 million meters within 1 second. Can you imagine that within 1 second, something can travel 300 million meters? Usain Bolt, when he was younger, we were told that Usain Bolt uses 9.86 seconds to complete 100 meters. And something can, within 1 second, travel 300 million meters within 1 second. It is unimaginable, right? Then the next characteristic they share is that they can all be propagated or transmitted with or without a medium. Okay, we use this ray, gamma ray, for sterilization purposes in industries. Before items are canned, they have to be passed through gamma ray so that it will sterilize whatever container the items or the product has to be put into. We use X-ray for a lot of purposes. One of it has to do with the medical use, where when there is a bone fracture, the X-ray is exposed to that part of the body, and it can give us a picture, an internal picture of the state of the bone. Okay. So these waves have diverse usage. Microwaves, for instance, is used for long distance communication, mobile phone, long distance communication, telecommunication. Okay. Radio waves, whatever we get from radio sets, wireless, TV signals, and so on and so on. So the electromagnetic waves have wider applications, and light, visible light, is part of the electromagnetic spectrum. The function of visible light actually is that it enables organisms to see, and so we say that it aids vision. So it is that part of the electromagnetic spectrum that aids vision. Please, any question? Okay, so apart from visible light aiding vision, what other applications of visible light can we talk about? Apart from enabling us to see, what other applications or usage can we talk about? Yes. Yes, anybody? Apart from its aiding vision, what other application or usage of visible light can we talk about? Janice, over to you.
Mr. Dia, please, can you say that it helps like plants prepare their food?
You can say it, very important. So we are basically looking at usage or applications to organisms, which include plants as well. So plants also use light, visible light, to prepare their food through the process of photosynthesis. So we've talked about aiding vision, and then for photosynthesis by plants. What other uses of, yes, Ella?
Please, they serve as a source of electrical energy.
It serves as a source of
Electrical energy.
electrical energy.
Not
Ella,
like, but then it helps generate electricity, like the use of solar panels and the rest. Like
then so you have
from
to.
the sun.
So it helps in photoelectricity. It is used in photoelectricity.
Yes.
Okay, through a process or an application known as photoelectric effect. Photoelectric effect. So the electricity generated through photoelectric effect is what we are terming as photoelectricity. So the question to the house is that, what is photoelectric effect? What is photoelectric effect? Yes, Ella, you said it. So tell us what you understand by photoelectric effect. Ella, you said it, so you break the ice for us.
What sir, please.
Okay, anybody else?
It's when light is absorbed, or light It's
Leo,
absorbed in the
Mate,
material.
anybody else? Oh, we are learning. So if you have an idea about, okay, Janice.
Please, I think it is when light is used to produce electricity.
And no. As a result of, okay, so let me
As
come
a
in.
result of
Photoelectric effect is defined as the phenomenon. A phenomenon is a natural occurrence. A phenomenon whereby electrons are emitted or removed from the surface of a metal. The phenomenon whereby electrons are removed or emitted from the surface of a metal when the metal surface is incidented with lights of appropriate wavelength and frequency. Ella.
Please, can you repeat it?
So the phenomenon whereby electrons are emitted from the surface of a metal when incidented, when the metal surface is incidented with lights of appropriate wavelength and frequency, meaning the incident light must have a certain quality, and the qualities are that they must have appropriate wavelength and frequency. So these are the conditions. Apart from the incident light having appropriate wavelength and frequency, we can also say that the incident light must have energy greater than the work function of the metal. Another condition is that the energy of the incident light must be greater than the work function of the material. These are the conditions necessary for photoelectric effects to occur. So for photoelectric effect to occur, these are the two main conditions. The wavelength of the incident light, okay, must be appropriate. The wavelength and then the frequency, okay, must be appropriate. This, okay, so when we get there, you understand what we mean by appropriate wavelength and frequency. Now the energy of the incident light we are talking about must be greater than the work function of the material. When we talk about work function is also energy. You see, materials become material as a result of the bonding of atoms. So if we are talking about sodium, material aluminum, the material aluminum comes to being as a result of the bonding between aluminum atoms. So several aluminum atoms are bonded covalently. So covalent bonding of several aluminum atoms to form the structure. Okay, so I'm representing this as aluminum atoms that are covalently bonded to form the structure of aluminum material. So the energy which holds these individual atoms together, the energy which holds these individual atoms, aluminum atoms together to form the structure is what forms the work function. So the work function of a material is due to the atomic bonding of that particular material. Okay, so for the atoms and then electrons, for the electrons to be free, the energy of the incident light must be greater such that it would overcome the energy which holds the individual atoms together. And when that condition is met, the atoms, the electrons surrounding individual atoms will be set free. Okay, so these are what we mean by photoelectric effects. Okay, so let's quickly move on and then look at sources of light. So as Ella said, we can also use visible light to generate electricity through photoelectric effect or through photoelectric effect. Is that okay? So that's one another use of that. So solar energy is converted to electrical energy by the use of solar cells. And this phenomenon is what we are calling as photoelectric effect. Let's look at sources of light. Sources. So here you'll be doing the talking so much so that when we get to technical areas, I also come in. Can we discuss some sources of light? Yes, sources of light. Mommy, tell us about some sources of light. Mommy.
The sun.
So, yeah, the sun. The sun. More views. Christine. Pardon? Ella.
Sir, please touch it.
Pardon?
Touch, like touchlight.
Okay, so torchlight. Theater. Theater.
Glowworm.
Pardon?
Glowworm.
Glowworm. Sawworm no. Bafwa. Bafwa. Oh, Bafwa is gone. Mommy, I called you. Jasmine.
Yes.
Fireflies.
Fireflies.
Yes, please.
Fireflies. Jasmine.
Yes.
Pardon?
You said, yeah, please. I said fireflies.
Jasmine said fireflies.
Yes, please.
Okay. Burning firewood. Burning firewood. Candle. Lighted bulb. Then what again? The moon. Moon. Stars.
Mr. Edia, please, I have a question.
Ask your question.
Please, I was told that the moon doesn't produce its own light.
Don't worry. We'll talk about it.
Okay.
All right. So look at these sources mentioned. Christine, are you there? Christine, are
Yes,
you there? Okay, so these sources can be grouped under sources that produce their own light, luminous bodies, and non-luminous bodies. Non-luminous bodies. Luminous bodies are bodies that produce their own light. So straight away, we can talk of the sun, the stars, fireflies, glowworm, burning firewood, candle, burning candle. You have to add burning or else it cannot. Lighted bulbs, etc. For non-luminous bodies, they do not produce their own light. An example is what you said, the moon. The moon reflects light from the sun. So we can talk of the moon. Even mirror. The mirror also reflects light. So this is what we are terming as luminous bodies and non-luminous bodies. Luminous bodies are bodies that produce their own light. Non-luminous bodies do not, but they reflect the light energy from a source. They say that when you visit the moon, the stones, the rocks on the surface of the moon, so shiny. So shiny. I think clearly the reason for which it reflects light from the sun. All right. Please, any question? Any question? Okay. Then aside these sources, we can also talk about incandescent bodies. Incandescent sources of light. Incandescent and fluorescent. Incandescent sources of light. Incandescent bodies are bodies that produce light, okay, as a result of it being heated enough. So they also produce light, but they can only produce light when their temperature has been increased so much. So when heated, they are able to radiate light energy. Okay. And I think you can identify examples that fall under this category for me. Yes. What sources can you refer to as incandescent bodies? Yes. What examples here can we put under incandescent bodies? Anybody? Oh, let's not waste time with this. When you have to come in, let's be quick and then shouldn't waste time. Bafua, Aisha, Eva, Jani, speak. Incandescent bodies. Extract them
Please,
out
the
of
sun.
the sun. The sun also,
Stars.
pardon?
Stars.
As for stars, we can't be sure because we don't experience the effect of the light, okay, produced. As for the sun, we know it produces dual purposes. It produces light and heat. But the stars, we wouldn't know whether it is incandescent or fluorescent because we don't feel the effect of the light produced by it directly. So the sun, yes, we are bold to put them there. Then we can also put burning firewood, candle, and then some lighted bulbs. Some of them we have with bulbs, we have what we call the tungsten filament. This is the